Okay, so welcome to GENI. My name is Niky Riga, and I work at the GENI project office. Welcome. So I'll get started with my talk. Thank you very much for coming, and I hope you enjoy the rest of the GENI conference. So I'm here just to give you an introduction for all of you that this is your first GENI conference of what is GENI, how are we building it, what type of experiments we're supporting. So GENI is a testbed that was built to explore the networks of the future, and let's see exactly how we do that. So this is just an outline. You're going to see the slide over and over, so I'm not going to go over it again. But let's start about what do we mean, why do we need a testbed in order to explore future internets at scale. So what is the problem with the current internet? So there are, first of all, science issues. We don't really understand. We built that thing. We started with a few nodes, and then suddenly there was an explosion. There were many, many nodes. We didn't really design it to go. We designed it to be scalable, and that's why it grows so much. But there was no real design behind how the internet is. And so we don't really understand it. It has a very complex behavior. It's very hard to study. So it will be very good if we could have a test bed that we can actually start testing this behavior and bring some science into how do we build this type of very large networks. Then we have society issues right now because we all rely on the internet working reliably and above all securely. We are doing our bank transactions through the internet. We're using it for every day at work. So there is a lot, we put a lot of trust to the internet working properly right now. And then we have innovation issues. So for those of you that you're researchers and you want to do research in networking, right now if you want to innovate, it's very hard because you can only innovate at the edges. You don't have access to the core of your network if you want to start, running your own protocol or study the behavior of the network. So the idea behind GENI is that we need a way to be able to study these things so that we have some science. We can actually prove things. We can actually start building new architectures. They might be better than what we have now. So GENI is a nationwide, it's a US project, and it builds like a nationwide infrastructure for people to be able to run these experiments at scale and be able to study new networking architectures at a scale that will give them some confidence that this might work if it was actually deployed. So GENI opens up very great opportunities for leading edge research. So if you want to try and figure out how the internet should have been built and what is a different way of building the internet, then you might want to consider trying out GENI. And it also give you the right tools in order to have rapid innovations. And I'm going to explain exactly how we envision this to work. The basic idea of GENI, in order to be able to support this, especially when we're talking about a testbed that multiple people are going to use, there are two amazing things. One is it should be open for people to use, so it should be easy for people to use and deploy their idea, and then it should be sliceable so that many people can use it at the same time, so that we can all try and innovate and test our ideas. And we should be able to do that as deep in the network as we can possibly can. So let me just give you an example. So these are, let's say, two of you that decide that you want to build your new internet architecture, and you're going to get a slice in GENI. And what do we mean by sliceable? It means you're going to get some compute resources where you're going to run. You're going to get access to a few routers in the network, as many as you need, and you're going to provision some links between your devices, whether they're compute resources, whether they're switches. And multiple people should do this at the same time, and they shouldn't interfere with each other experiments. So someone should be able to run, let's say, their normal internet, have like all IP configured, and someone else want to do something completely different, not use IP. And they should both be able to run in the same testbed and share the same infrastructure. So the idea is that GENI wants to enable this idea of we can run many future internets in parallel, and one shouldn't interfere with the other. It should be isolated one from the other. So what is the GENI concept? And now I'm going to tell you the GENI story. For those of you that this is not the first GEC, I'm sure you've heard this nice story before. So this is our famous test tube guy. He's an experimenter, and he had an idea. And I'm sure this is an idea you've heard many people talking about, that the internet was built to connect computers and resources, but we are actually using it in order to connect peoples to content. And maybe the fact that we are using something that was not really built for this, maybe the architecture we came up is not the best one. So he wants to design a new architecture, a new routing protocol, and then he publishes his paper and he gets all this will never work, this is not scalable, this is not secure, all the feedback we get when we go to networking conference proposing to change the world. So he goes to GENI and he decides to try out his idea, actually implement his new routing protocol. So he gets a few resources. He makes, a moderate slice so that he can run his experiment, try out. He might have some wireless resources, some routers in the middle. He might have access to some cloud infrastructure in the edges. And he starts testing and building his idea and his experiment. And he sees that, this is actually, you can actually work with it, and it's actually work as well as he thought. So he started extending his slice. He started with a moderate number of resources. Now he expands and builds like a much bigger slice and keeps testing his ideas to see whether they're scalable or not. And when he feels confident enough, he can actually open this up and have real users start using his idea. And you can imagine that, you can have, because internet, again, I said is sliceable, you can imagine that one slice runs the old internet, whatever we know now. Slice one is his slice, right? Is running his new future internet routing. And then you can have other experimenters doing other stuff within GENI. So he gets, new people download maybe an app, start using his own protocol. And, it was very successful. He has a startup, it's being sold, he's a millionaire. He moves out to I don't know where. So this is a happy story about how we envision the experiments in GENI, and not, of course, all of them are going to be happy stories like this, but the idea is that you have an idea and you can test it out. You can start small to build your new idea, and then you can slowly expand. And if you want, bring in users using your own idea. In the meantime, while he was building his network, there are other people that are trying to see different aspects of how to build networks and have their own ideas, and they run in these other slices I saw before, slice 3, slice 4, and they can all run in parallel, and you can all, if they decide to open it up to users, then you can use other people's ideas. So why do we build GENI? GENI is meant to enable exactly at scale experiments on something you cannot do in your lab. In your lab, you can have a few computers, you can have one rack, you can get resources. The idea is that GENI will enable you to do this at scale, at a realistic scale with realistic delay, so you can get resources across the country. You should be able to do repeatable experiments, especially when you're in the development phase. So if you're just starting out building your protocol, you want to be able to repeat the experiment so that you can debug your software, but you also want to do it in the wild to see if I was to deploy this in the internet tomorrow, how would it work, right? And the idea is that you should be able to get real users. So if you feel confident enough that your idea, your application will work, you want to open it up to users so that they can use it and see how it behaves. And it should give you ways to make it easy to do your experiment. So it should make it easy for you to collect measurements, to see what's happening. It should make it easy for you to instrument. Because once you have an experiment that is of a large scale, and we're talking about, tens to hundreds of nodes, then it's very hard to go and configure each one of them, right? You need to have a nice way to instrument all your experiment together. And there should be a story that if the experiments are successful, how are we going to migrate this to the internet? So GENI is meant for people to try out their ideas on the GENI and then move them to the real world if they're successful. So how do we go about doing that? How are we building GENI? So first, right now, we're still trying to grow the GENI's footprint across the country. So here you see all the states that are currently GENI enabled, and these are the regional networks. All the dots and the small triangles basically show GENI resources, whether they're wireless or GENI racks and compute resources. And we also, we're trying to actually build as much as we can this footprint so that we can give what we promise of a large-scale test bed for people to use and try out their ideas. So how are we going to go about doing that? Building something from scratch, it's very expensive. It's really hard. So GENI is trying to GENI enable different type of infrastructure, and it's basically a federation. So when GENI started, there were already test beds out there. You might have heard of Planet Lab or EmuLab or Orbit. They were built when GENI started, these test beds were out there, and the idea is that we're going to try and GENI enable everything that is out there, different infrastructure, so that we don't have to build it from scratch. We won't start, starting deploying GENI equipment from scratch, but we'll try to take advantage of whatever is there. And so you have backbones, you have campuses, you might have commercial clouds. The idea is to give you a way to have access to all the resources that are out there in a common way so that you can get the resources you need to run your experiment. So how are we going to do this at scale? Because again, I said that this is expensive. So we're trying to GENI enable, and I'm going to explain what GENI enable means, existing hardware and existing test beds, so that the experimenters have a common way of getting access to these resources, and also enable slicing in them, because many of these resources right now, they cannot support multiple users at the same time. And then so a few good examples are like switches that we try to GENI enable, or WiMAX base stations, so that multiple people can run different ideas on the WiMAX base station and share the same infrastructure. And then we're going to deploy it in what we call GENI enabled campuses. And then slowly we're going to grow, and this is just a nut-scale GENI prototype. And I'm going to talk about why do we start from campuses. This is where research is happening. This is where people are willing to try crazy new ideas. So it seems like the good place to start building GENI at. And this is a good example of a GENI-enabled campus, Georgia Tech. So they have a very big footprint of GENI-enabled resources there, that they are interconnected, and they want to actually connect the students' dorms to GENI directly. So imagine the idea that in your dorm you will have two Ethernet plugs. One will be in the internet, the other will give you direct access to GENI. That's what they are trying to do. And so there's a trial of GENI enabling many commercial equipments, like switches, phones, WiMAX base station, racks. We're trying to GENI enable a lot of commercial equipment so that we can start building this. And the idea is that many campuses already have these resources. So if we find a way to just GENI enable them by updating the software, for example, that means all the campuses do not have to buy new equipment. And this is the envisioned architecture. So we have to first GENI enable the backbone. That's Internet to all national lambda rate. Try to GENI enable and give access to our experimenters in the core of the network. Then moving closer to the edges of the network, we need to GENI enable the regionals, right? So that we can slice the regional network so that people can get a slice there as well and get access to how their traffic is routed. And then we go to the edge where is the GENI-enabled campuses that I have been talking, the universities, right? So that then when you get a slice in all these places, and you can actually control these different places in the network. And that's how we give deprogrammability to our users. Okay? So current efforts for the GENI build-out. We have many WiMAX base stations that are being deployed around the country, and I'm going to show you a list of where exactly right now we are putting WiMAX base stations. We're trying to have more open flow switches that give us this capability of slicing a resource within the network. So that gives you deprogrammability and sliceability as deep in the network as the experimenter needs. And we're trying to deploy GENI racks to campuses so that there is a uniform resource that the experimenter can have and get to run their resources, their experiments. So GENI racks, what are the GENI racks? I'm sure that, how many of you have heard about the GENI racks? Okay, most of you. So what are these GENI racks? So when we first built GENI, like 2-3 years ago, we started with a small prototype, and in every campus we had like custom hardware and an open flow switch, and we decided that it will be much easier if we build one rack that is already GENI enabled, that the campus can buy as a whole, install it in the campus, and then suddenly they will be GENI enabled. That doesn't mean they cannot GENI enable other parts of the network, like already existing switches, but this is a very good way to get them started. And in GENI, we have 2 different teams that do that. One is out of HP, and we call them the InstaGENI racks, and you're going to hear this throughout the conference, InstaGENI, and then the other team is from IBM and out of RENCI, and they're called the ExoGENI racks. And for those of you that are attending tutorials, you see an orange dot. We're going to forget this for now. And then you might have a blue or a green. This means that for some tutorials, we're going to use the InstaGENI racks, then you have a green dot. Or if you're using ExoGENI racks, then you have a blue dot, right? That's all that these dots mean. And we're deploying them around the country. And let me just very briefly talk about each type of rack. So for the ExoGENI racks, the GENI project office has funded 14 of them. They're more high-end racks. They're more capable. They have more nodes, more memory, higher data interfaces. And there's a partnership between Renzi, Duke, and IBM. So these are, and you can find all this information online. Don't try to read the slides, and the slides will be online. The whole idea is a more high-end, more expensive rack. And each rack is basically a small network cloud, and it's based on OpenStack. And when the build-out finishes, we're going to have at least 14 of them around the country. Now, on the other hand, the InstaGenie racks are not as powerful, but they're also cheaper. So there's, they're less expensive for a campus, to get started. And also the idea is that you will get some resources, but the rack will be mostly empty to put your own stuff. So if you have your own lab, if you have different type of resources that you want to connect to GENI, then you basically get a rack with a few compute resources there, and you can add your own, or you can keep building it in the future as you try to expand your GENI footprint in your campus. So it has 5 experiment nodes, and it also has an OpenFlow switch. And these are our 2 different type of racks. Now, I talked about the WiMAX deployments. And again, these slides are going to be online, so I'm not going to go through all of them. It's just all the places around the country that we're deploying a WiMAX base station. The idea that all these WiMAX base stations are going to be connected in a layer 2 network, and then an experimenter can get access to the different WiMAX base stations and connect between sites. And these are just more sites. And so now I've talked about the edges, right? How are we GENI enabling the edges? I talked about WiMAX base station that you can install in your campus, or you can get a GENI rack and install it in your campus, and this is in the edge of the network. But I said we also want to give access to the core of the network to experimenters, so we also want to GENI enable the core. So this is an example of a regional network. So this is how Scenic is trying to GENI enable their network, and basically they're deploying OpenFlow switches within their network and giving access to these switches to GENI experimenters. So then you can go from your campus to your regional, and you have access how your traffic is routed inside the regional. And then this, we're also trying to GENI enable the backbone. So this is Internet 2 has announced a build out of OpenFlow switches. They're building a new infrastructure that is all OpenFlow. And the idea is they're going to allow GENI experimenters to get access to these OpenFlow switches in the backbone. And if you manage to GENI enable in all these places your network, then suddenly you can build at scale GENI. You have your edges, you have your regional network GENI enabled, you have GENI enabled the core, and now the experimenter can get control from the edge all the way to the middle of the network. So how are we doing in terms of having people actually start using GENI, right? So the whole idea, we're trying to build it. Also, I didn't mention it, that we built GENI in spiral. So before I said that we started by people using their own custom hardware and trying to GENI enable, and then we moved to the GENI racks. So we try to build something small. We have people using it. We get feedback from how well that works or doesn't work, and we go to the next spiral when we're trying to build a bigger GENI that is better suited for the needs of our experimenters. So how are we doing about using GENI? So it's slowly getting tractions with experimenters in different universities. People have started using it. And of course, because we're still building it, there is a type of friction between trying to build GENI and people trying to use it. And the people that have already, have ideas, they have experience in using GENI, they push GENI to its limit. So they run out of resources. They come into, limitations that we haven't yet been able to solve. So the main thing that we get as a feedback from experimenters, they need more GENI resources. So we need to get more of these GENI racks out there. We need to GENI enable more places in the network, because they're running out of resources when they want to run these large-scale experiments. So this is just how are we growing currently the use of GENI. So this is over the different GECs for the 2 different type of racks. You see that the ExoGENI racks started much later, while for InstaGENI racks, because they were actually based on ProtoGENI and EmuLab, we have statistics from when it was only ProtoGENI and we didn't have the racks yet. And here we see, I know these graphs are hard to read, but the main thing is that here you see these are the new InstaGENI racks, and how slowly as we deploy them, people start using them, right? So this is just how how are we growing experimenters in the different type of racks in GENI. And I just want to present you what type of research people are doing in GENI, so you can see what type of research we can support. So back in GEC9, we had the first people that trying to use GENI. And one of the experiments there was active CDN. It was out of the Columbia University. What they wanted to do is get control in the routers in the middle of the network, so that when, for example, you trying to download something and they decide they want to install a new software in the middle of the network in your router. So you see the places where they have actual their own routers, and the edges where we're in the topology that they run their experiment. Another demo we had was about weather nowcasting, and this is a very good example of trying to GENI enable a commercial infrastructure. So what they did is that they were getting measurements from a radar. So the idea with nowcasting is that you don't want to forecast the weather for the next day. You want to forecast the weather for the next 5 minutes. And this is really important in case of tornadoes. Like, is it passed from here, from my house? Do I need to evacuate? So they were having measurements from radars, and the radar was in Puerto Rico, and they wanted to very quickly process that. So they had a slice in Amazon EC2. They were passing the data through EC2. They were processing them and then getting them back to GENI. So this is a very good example of an experiment that actually made use of how we can GENI enable commercial resources. Another set of experimenters out of Stanford University, they were trying to do network load balancing, and they were using all the OpenFlow switches we had at the time in GENI, and they were trying to actually make decisions about how to route their traffic within the network, in the core of the network. So they were using 5 OpenFlow switches in NLR and 5 OpenFlow switches in Internet 2 to make decisions inside the network about how their traffic should be routed. Now, I don't know how many of you have heard of FIA, Future Internet Architecture. So NSF a few years ago, maybe 2 or 3 years ago, they started funding under this big umbrella that was called Future Internet Architecture, and they funded 4 major projects. And they are all working with GENI to try out their ideas, and I'm just going to present a couple. So one is Mobility First, and it's out of the Rutgers University. It's like actually a big list of universities that are collaborating. And their idea is that everyone now has a mobile device, so internet and connectivity should be mobile. So when we're designing the internet architecture, we should take this into account. The first thing we have to keep in mind while we're designing is mobility. And they're trying to come up with a new internet architecture that has mobility in mind. In GEC12, they did a demo using the GENI resources that are there on the map. It's not important, and they're still trying, to build and expand their footprint within GENI and testing out their ideas. Another future internet architecture program is XIA, which is the Expressive Internet Architecture. And their idea is we don't know what the internet is going to be used in the future. It started to connect resources. It ended up being used for content, but who knows what we're going to use internet in the future. So we should take this into account where we're building internet, and we should have something that is application agnostic, and you can actually modify your routing very easily, so that you're not tied to only IP. If you want another routing algorithm, you can just deploy it very easily. And they actually had a demo in GEC17, I want to say, and they actually deployed, they had a layer 2 network that were running their own routing protocol, and they had a connection also with Japan. So they had the server or the client running in Japan, the server running in US, and the whole network was layer 2 to test out their new idea. So we also see it in a big increase in the research community about future internet architecture research. We are doing, every year we're having one GENI workshop where people that are doing the research in GENI can actually publish their ideas there. It's usually in spring. We just had one in the previous GEC in Utah. And also every summer, we have a summer camp. And tomorrow in the plenary, we're going to present the outbrief of this year's summer camp that was in Connecticut. And the idea in the summer camp is that we go for 5 days in one university, only with students, and try to teach them how to use GENI and also help them implement their own research idea in GENI. So all the students are doing a small project. We also try to increase the use of GENI in classrooms So for those of you that are professors, if you're teaching a networking class and you want your student to get some hands-on experience, we'll be very happy to talk to you. And GENI Albrecht is organizing, she's already organized one workshop in conjunction with the GEC17, and she's planning to do yet another workshop only for educators, for people that want to use GENI in the classroom. And we also, in an effort to expand the use of GENI, we are going to different networking conferences and giving tutorials. So, you know, if keep your eyes open. We might be coming to a next tutorial, to do a tutorial in another conference as well. This is just a list of the most recent one. We have been updating our GENI wiki. So we know that there is a problem. So for example, now if you Google search GENI, most probably you're going to get to a site that will want to find out your family history, genealogy site. Yeah, and we get many questions about this site. And we have a GENI wiki. We're actually trying to document everything. So the best way is to say GENI and network next to it. So for whatever you're looking in GENI, that will actually help you get more useful results in Google. We just updated our newcomer page. So this is, I think, it's probably going to be useful to all of you. So if you go to geni.net and you press the GENI wiki, there is a newcomers icon that will take you to this page that basically explains the important GENI concepts, how do you get an account, what is the idea behind GENI. So maybe it's a very good place to start if you have never heard of GENI before. So this is a list of people that have already started using GENI in the classroom. These are also the type of people that are usually get limitations in terms of resources because they have, you know, 30 people in their classroom and then everyone is trying to access GENI and run their experiment at the same time. So they are the ones that are usually come back and report bugs and say, we need more resources. You need to expand this. We want to use it in the classroom. We need more resources to make this more successful. And we have, in the spring of 2013, we had a bunch of people using it as a one-time seminar or throughout the class. They were using GENI in their classroom, and these are the planned ones for 2013 in fall. So how many of you have heard of US Ignite? Good. Okay. So US Ignite is, again, an effort coming out of NSF that is trying to fund people doing next-generation applications, and especially for social benefits. So think health, emergency, fire departments, police, applications that are useful in the social community. And so in order to they are trying to build gigabit applications and services. And they want to do that, of course, in an ultra-high-speed network that is deeply programmable, especially when you're trying to build stuff that you cannot support in the internet now, even if it's just because you don't have enough bandwidth. You need to be able to do smart decisions within the network. So this seems to be like a nice collaboration. We are building the infrastructure. We are trying to build a fast infrastructure for people to use that is deeply programmable. And US Ignite, on the other hand, they're trying to build applications. So this seems that like these two things should match, and we're actually in tight collaboration with many of the projects that US Ignite funds, and they're trying to run their applications within GENI. So right now, I'm sure you didn't count all the dots in the map that I saw in the beginning, but you can imagine we have presence in like 30 to 40 campuses. And we really need to expand this. If we're talking about at-scale experiments, we need to get to 200 and 200 campuses. So how exactly are we doing that? I said that we're trying to GENI-enable the campuses, and there is an ongoing spiral development, trying to get more and more campuses involved, whether they want to GENI-enable their existing infrastructure or their existing test bed, or whether they want to just buy a GENI rack, which is the easy way to get connected into GENI. So what's next for GENI? I said about, we started with very few campuses. Now we are here, and this is our solicitation 3. So funding in GENI comes in solicitation. The solicitation 3 is the one that actually funds the build-out and the campuses, and right now we're in the middle of trying to get solicitation 4 to fund mostly support for tools and for user experiments. So instead of the solicitation 3 effort, Larry Landweber, and you might see him around. So if you're interested in GENI enabling your campus and you're not in the list of solicitation-free campuses that are going to be GENI enabled in the next few years, then this is the person to talk to. He's trying to get more and more interest from campuses. He already has a big list of campuses that are interested, and we still don't have funding for them in order to GENI enable their campus. He's working closely with NSF to try and fund this type of efforts if a university wants to add to GENI enable their infrastructure. So if you're interested, just find Larry Landweber. He's around the hall, and talk to him. I'm sure he'll be very interested in talking to you. We are ramping up experimenter workshops and trainings for IT staff. So Indiana and the GRNOC are basically going around the universities and giving tutorials and workshops about GENI for IT people. And we have a lot of interest, and we have actually people on the wait list, both for the workshops and for GENI enabling their campuses. We also have an international collaboration. So in the previous GEC, we actually had an experimenter that wanted to run their experiment across different countries. They were using geoimaging, and it made sense for them that they wanted to be able to process in different parts of the world the information they got from the satellite. So we had like an international slice build-up between Germany, Belgium, Brazil, Japan, and the US. And they tried it out there. And this is just some of GENI's international collaborations. OK, now I'm hoping to go to something that will be a little bit more interesting and fun, because I'm just going to try and showcase how we are using GENI. And I'm going to do a demo here. And it's a live demo. Hopefully, it's going to work. But before I do that, I just want to present and talk about what is then a view of an experimenter in GENI. I described all this, but how is this exposed to the experimenter? We're putting these racks, we're putting WiMAX base station, how an experimenter gets access to them. And one of the big things in GENI is that if you're an experimenter, it's really hard to ramp up in terminology. So if you're attending tutorials, you're going to be hit with new terms all the time. So I'll just start here, giving you an idea of the terms you're going to be hearing throughout the conference. And I talked before about sliceability. We want to be able to slice the network. So the first thing that an experimenter sees is a slice, right? Every experimenter, in order to run an experiment in GENI, needs to get a slice. And slice is this, it's an empty bag of resources. It doesn't really contain anything. It's just an abstraction that describes all the resources across the GENI footprint that you're going to get in order to run your experiment. And the idea is that these slices isolate experiments so that we can run many of the slices in parallel, right? So the idea is that, for example, if you're attending a tutorial, each one of you is going to run one experiment. You're all going to use GENI, and each experiment shouldn't interfere with the other, right? So the first thing you're going to get in GENI is a slice. And slice is basically ensure that experimenters are not going to interfere one with the other. So how do we do that? There are what we call slice authorities. And remember, GENI is a federation, so there's not one slice authority in GENI that gives out all slices to people. There are multiple authorities that can give slices out of GENI. And then we have what we call an aggregate, which is the actual place where you get resources. So slice is this abstraction, this empty bag that you're going to put stuff, and aggregates are the one that will actually give you actual things to put in your slice. So you'll go and say, I want 4 VMs, I want a VLAN, I want a link, I want access to this WiMAX base station, and these are all the aggregates. They are the servers that are going to give you access to real resources. And for example, for the racks that I talked before, the InstaGENI and the ExoGENI rack, every rack runs its own aggregate manager, right? So if you want to get access to the ExoGENI rack in Renzi, you have to talk to a manager there and say, I want 4 VMs, or I want 2 raw PCs from them. And so the first thing you do as an experimenter is that you talk to the slice authority and register your experiment as a new slice. And after you get back something we call a slice credential, which basically says, yes, I recognize you, you can have access to GENI, and here, go get this slice and go and build out, put there the part of GENI that you're interested in using for this experiment. Then you can use this token that you got from the slice authority and actually go and talk to the different aggregate managers in order to get your resources, right? So you first need a token that says, yes, I'm an experimenter of GENI and I'm building a new slice. And then you go and you actually start adding resources to your slice. Now, another term you're going to hear, we have slice, of course, and now we have sliver. What is a sliver? And I know that it's getting very confusing. So slice is a slice of the whole network. Slice, you can imagine, is your slice of GENI. GENI is a very big thing, and you get your own slice, which is just a part of it. Sliver is just what you're getting in one aggregate manager. So imagine, again, that you have the rack in Utah, and you want to get 3 resources. This will be your sliver in a specific aggregate. You have 3 resources out of all the resources that they can give you, and this is your sliver. And this is, all these slivers is what makes up your slice. So imagine that in each one of these places, you get a small part that is your own sliver, and this is how you make your experiment that is compound of all these slivers. Now, we need a way to talk between the experimenter needs to talk to these aggregates. We need a language to be able to communicate. And we use RSpecs. And RSpecs are just XML documents. So you basically need a way to describe what you want from an aggregate. I said before, you can get 3 machines and a link and access to a WiMAX base station. How do you do that? You need to write a document, an XML document, that describes exactly what you want to do. And I know, writing XML document is not fun. So in GENI, we try to automate this for the experimenter. But if you're wondering, how do I talk? How do I communicate what I want? This is what's happening under the covers. You just submit an XML document, you describe exactly what you want and your topology, and you send it to the aggregate and get back your resources. Now, how many RSpecs do we have in GENI? And we basically have 3 different types of RSpecs. The first one is the advertisement RSpec, which basically says an aggregate will send it to you to describe all the resources that they have, right? You need a way to say, this person can give me access to a WiMAX base station, this person has compute resources, they have OpenFlow switches, they can give me links between my resources. And in order to do that, so you go to an aggregate and you say, tell me what you have, and that aggregate sends you back a big XML document that describes all the resources they have, and this is what we call an advertisement RSpec. Then we have what we call a request RSpec, which is basically, it's the RSpec that you write, describing your topology. What do you want out of each AM? And you can say, I want 3 links and connecting these 3 different resources. So basically, this basically describes your experiment. And then we have a third type of RSpec, which is the manifest RSpec, which basically says what you actually have. So imagine that you want to run an experiment with 3 VMs, but you don't care which VMs are those, and you don't really care where they are. So you just send it and it says, please give me 3 VMs. So the manifest will give you all the information you need in order to access your resources. It will say the IP address, how do you get access to it, what type of memory it has, any information about the actual resources that you own. Okay? So the advertisement aspect describes all the resources of an aggregate. The request describes your own experiment. And the manifest describes what you actually got in a specific aggregate with details. Okay. So now to the demo that I said I'm going to do. I'm going to create a slice. So I'm going to go talk to the slice authority and say, I want to run a new experiment. And I'm going to register my slice there. And then I'm going to only use 1 aggregate. This is just a demo to show you how it can be done. And I'm going to request just 2 VMs connected by a link, right? A very, very simple topology. And I'm going to, in my RSpec, I'm going to install and run some software to automate my experiment. So these are the steps that I'm going to do. I'm going to do them one by one, so you don't need to keep track of this. So this will be interesting. Sorry, I need to. Okay, this won't work. Okay. So the first thing I said that I need to go talk to a slice authority in order to get my slice. So in GENI, we implemented and rolled out to experimenters less than a year ago what we call the GENI portal, which basically has a slice authority that runs at the GENI project office. And this is just a portal that gives you access to be able to request the slices from the slice authority. Okay? So the first thing I do, I go to the portal, and I try to log in. And I have an account here, so I'll just log in. And notice there that there were other options for me. So GENI has integrated the clearinghouse, the slice authority that we run in the GENI project office, actually has is using InCommon. And InCommon is just a way, you can imagine it like as a single sign-on for universities. So I'm sure you've all used the capability that, oh, I'm going to sign in with my Google account to a completely different service that has nothing to do with Google. And this is single sign-on. And InCommon is just a federation between research institutions and universities that actually provide a very similar service that you can use your university account in order to log into other people's services. And the portal is just one of these services. So if you have an account with your university and your university is a member of InCommon, you automatically get access to the GENI portal. You can just use those username and password to log in here. And we're going to do this in more detail in the next session in the tutorial. So all the research in GENI is organized in projects. So in order to run an experiment in GENI, you need to have a project. And a project is usually owned by the person that is doing the research, a PI, a faculty member that is going to sponsor this type of research. So let's try and go here to the GEC17 project. And as I said, the first thing we need to do when we start an experiment is to actually create a slice. Okay, so this will be a Hello GENI slice. It's going to be a very simple experiment. Okay, and now I see here all the options that I have of what can I do in my slice. And in order to reserve resources, I'm going to use a tool that is called FLAG, which is a graphical tool that will help me reserve the resources I need. So I'll go here and press the Launch FLAG button. And so FLAG is a tool that was written out of the Utah University. It was originally to support Proto-GENI, and now it supports all of the aggregates that speak the GENI API, a common API to, so that we can grab you give it a request RSpec and it gives you back resources. And here are all the different aggregates that are currently available through the GENI portal. And we see some ExoGENI racks, some InsoGENI racks, some Proto-GENI sites. So we'll wait until it loads. So it takes some time because what happens now, remember the advertisement RSpec that I was talking before, it goes out to each one of these AMs and try to see what resources every of these aggregates has. So what do they have to offer in order to be able to advertise it to the experimenter in a nice way that the experimenter can use in order to draw their slice. Okay, so now everything is loaded. And you see here that I have access to PCs, and PCs are raw computers if you need for your experiment, or just access to VMs. And you can go and basically draw your topology here, and connect, draw links between your nodes. And if you go here, you can see some more information you can set up. And I also said that I want to instrument my experiment so that when my nodes boot up, they will automatically download and install some software. And because I'm very bad in typing and I'm going to do a mistake, what I have done is that I have already have my RSpec here. Let me just find it. So this is an already made RSpec XML document that describes the actual topology that I want for this experiment, the 2VM topology with one link. And in FLAG, except from drawing your topology, you can also go here that says import and import it from an RSpec that you have saved somewhere out on the web. And this is a generic RSpec, right? I said before that you were able to say, I just want 2 VMs and a link. And that's what I did in this RSpec that I have, and I'm going to show it to you in just a second. So here it says, where do you want to create this slice? And just for the purpose of this, let's go to, okay, and you see that I just have the same that I had before. There are just 2 VMs connected by one link. And if I go here, I see that I've actually added an install service, and this is described what type of software I want to be installed in the nodes the moment they are going to boot up. And here I also have an execute service, which means once the node boots up, please execute this script for me. So I have a way of downloading custom software to my nodes, and then I have a way of invoking the installation of this software with a script. Okay? And I'm not going to show you the client is extremely similar, and then and then you click submit, which I add here. I did it in one click. And this will take a while. And why this takes a while? Because you actually get access to real resources. So the aggregate manager needs to actually go, find the resources for you, boot them, install the OS if it's not the default OS. If you chose a different OS, it needs to actually install the new OS and boot the machines for you, and actually install your software. So this is going to take a while. And while we're waiting for the resources to come up and get ready, let me show you a little bit the RSpec, which is here. And again, you're never going to have to write an RSpec, right? There are tools in GENI that they can do that, and Flag is one of these tools that can write RSpecs for you. I just want to show you a little bit of how this thing looks. So here, I said I want a node, and I don't care if it's a raw PC, so I can have, this can be a VM. So this says, that it's not an exclusive resource. I'm sharing this server with other people that have VMs on the same host, okay? And here I have the services that says, when my node boots up, please run the script for me and download the software from this URL that I have provided that has all the custom software I need for my experiment. And then if I go down, I'll see that I also, here, I specify a link, and I'm saying this is a link between my 2 hosts, right? Okay? And now if you're wondering about what does the install script does, I can very briefly show it to you. It doesn't do anything fun. It doesn't do anything much. It's just basically check, have I run this script before? And if I haven't, then, just put a file there that says I've run this before. So because this script is invoked every time your nodes boot, so if you want to reboot your node, you don't necessarily want to run the same script all over again. So it goes and install some packages for me. And then if this is the server, then start the server for me. If you're just booting up, and then it says if you're the client, then run this experiment for me, right? So it basically fully automates my experiment. So let's go see what's happening to our resources. So you saw now that the background in Flag turned yellow, and that means that the aggregate is actually trying to provision the resources for me. It agreed to give me these resources, but they're not up yet. And once they're up, the background will turn green. So now, for this very simple experiment, I'm running just a web server on the server, and we can just go and visit and see what's happening there. So Flag has this button here that says visit that will actually open, my host on port 80, and it installed the web server. And if I want to see the statistics of the web server, I can just click here. And I had in my script, in my automated script, the client start automatically having requests to the server, and the same I had iperf running. Okay, so, and then once I'm done, this is a very other important step, that once I'm done with my experiment, then I should delete my resources. This is a shared test, but then other people are using it. And I said before that we had experimenters that are reaching the limits. They're running out of resources. So it's always good, once you're done, you run an experiment, save all your work, don't lose your work, save your results, and then please delete your resources so that other people can have access to them. Okay, so once you're done with your experiment, you can just click delete and delete your resources here. Okay, and so hopefully GENI is that as easy as that to use. And if you're taking, how many of you are taking a tutorial in the conference? Cool, so you're all gonna do this very simple thing, and you're actually going to do more complicated than this, but you're going to get a feeling and see how this works for yourself in the next sessions. Okay. So I created my slice, I launched the tool that I wanted, I drew my topology, and then I created the sliver, you know, that had my 2 VMs and a link. So basically then, just to remind you, I waited until the background was green, which means that my sliver was ready, my resources were ready. This is the request RSpec. Of course, we're not going to read it. And this is the manifest RSpec I got back. And the only thing to note here is that I asked for 2 VMs. And I know that it's hard to see, and it doesn't really matter what it says. The idea is that it tells me which PC exactly I got. Out of the 600 PCs that Utah has in their proto-GENI installation, which specific ones are mine. So that's what the manifest RSpec is for, to describe the exact resources that I got. Okay? So you can do this at home. For those of you that are taking tutorials here, we're going to go through this process a few times in the different tutorials. So if you go to this GENI wiki that I mentioned before, remember you go to geni.net, and you click where it says GENI wiki, and then there are multiple icons for the different roles of people having in GENI, and one of them is experimenters. So if you go to the experimenter icon, which is there, then there is this nice lamp bulb that says tutorials, and there are actually multiple tutorials there. This is a very, very simple one, but you will find a wealth of other type of tutorials, more complicated, that you might want to try it at home. You should also participate to hands-on tutorials. Even if you haven't registered, you can show up. If it's not full, you might be able to try it out. And get a GENI account. So I'm going to go back to this one, and before I explain the blue and the green dot, now I'm going to explain the orange dot. The orange dot means you already have an account. If you don't have an orange dot and you want to go to a tutorial, please visit the help desk out there in order to get an account. And even if you're not doing a tutorial but you want to try it at home, this is a good time for you to get an account. Please go to the help desk and get a GENI account. And basically, these are the ways you can get a GENI account. So again, if you go to geni.net and you go to the GENI wiki under the experimenters, it will have a link all the way on the top that says sign up. And it has all the details about how you can get a GENI account. You can also get an account here at the GEC. You can go to the experimenter help desk that is out there. Someone is going to be there today and tomorrow. As long as we have tutorials, someone should be there to help you get an account. Or if you come to the experimenter drop-in session, which is tomorrow, we can help you get an account there, or the coding sprint on Tuesday. I'm going to go over the agenda very briefly to explain the different things that are available during the conference. So I know you cannot see this, but you all have a copy of this in the leaflet that they gave you. So everything, so you probably already figured out that if you're a newcomer, we've tried to put a green dot to all the sessions that are good for newcomers. This has nothing to do with the green dot on your badge. This is just to specify that, these are the sessions that are good for newcomers. But depending on what is your role in GENI, so I saw that many people are networking people, network admins. So you might also want to look some of the other sessions. For example, there is the campus deployment and research collaboration session that might be more interest to you than doing yet another GENI tutorial. So go through the sessions and please ask questions if you have about which session is better to attend. If you see a laptop in the agenda, that means that it's required for you to bring a laptop so that you can participate in the hands-on session of the tutorial. And for all the tutorials, we have tried to put all our software in one VM. So how many of you have already downloaded the VM? Wow, good, okay. So if you haven't downloaded the VM, please don't try to do it now, because we had this happen one year and we brought down no one could do any tutorials because there was no bandwidth left for people actually trying to download the VM. We have the VM in USB sticks at the experimenter help table. So if you haven't downloaded, it's okay, just go there and use one of the USB sticks to download the VM on your machine. Now also tomorrow, In the last session, there is a session here that's called Experimenter Drop-In. And this is a very, very informal session. Me and other people from the GENI project office are going to be there. And the idea is that you can come, either try tutorials that you didn't go, tutorials you didn't get a chance to finish, or if you already have an idea about your experiment, you can start designing your experiment there, and we'll be there to help you design your experiment. And we are actually doing the same during the coding sprint. So officially, the GEC finishes on Tuesday after lunch. This is the official end time. After that, we have what we call the coding sprint, where basically developers of GENI get together and they try to develop and write code together while they're all in the same room. Again, GENI is a federation, and it's built by many different people in many different places. So it's nice when we meet together to everyone sit down around the table and try to debug any problems they're having. But also experimenters are welcome there. We will try, if you have an idea about your experiment, that is the best time to get started, because they're also going to be the developers in the room. So if you have any problems, if you're trying to run your experiment and you are running into any problems, you can actually ask the people that are responsible and help you with it. So like this conference, we meet 3 times per year. We meet once in the spring, once in the summer, and one in the winter. And the next one is the GEC18th is going to be in the end of October in New York Poly. So please, come again, especially if you have an interest, come again. And for academics, we also have travel grants. So if you have a student that you want to send, or a colleague, a friend of yours in the graduate school that doesn't have funding to attend one of these GECs, but they really want to, please let them know that there are travel grant available, that we fund people to come and to come to these GENI conferences. Questions? No questions? Nothing? Questions about the agenda?
Yeah, so it was kind of clear that...
I think it's a very big room.
So it was clear that switches and routers can be shared with GENI, but can links between them be shared for various slices and slivers?
So this actually depends on what type of links we're talking. If you're talking about at the layer 2, we're trying to use VLANs. So every experimenter has its own VLAN between racks, so that is not shared. We do have some shared VLANs, so when people don't care so much about isolation and repeatability, they can actually share the same VLAN. But if you're talking about the same physical link, then yes, but we're trying to split it with VLAN so that people actually do get their isolation. Other questions? Tutorials, where you want to go?
What did you say about when we need the VM?
You will need the VM immediately after this session. So every place that has a laptop, which means it's a hands-on session, you will need the VM in order to be able to participate. And in order to install the VM, you also need to download VirtualBox. So this is a VM that runs in VirtualBox. If you don't have VirtualBox on your machine, just install it.
Just for fun, is the virtual infrastructure that you use to support virtualization or VMs across the GENI network, or is that all based on VirtualBox?
Oh, no. Different
Products and things like that?
different aggregates use different type of virtualization. So the ExoGENI racks are based on OpenStack and Amazon EC2 clouds. The InstaGENI racks, they have 2 different type of VMs. One is Linux containers, which basically means that you are all sharing the same kernel and then you have a separate user space. And this is good because it's more scalable. You can get way more people using the same machine. And they also, for people that want real VMs, they want their own kernel, then they have Zen VMs. And these are the actual, currently, the two virtualization technologies we have in the GENI racks. But you can imagine you could use, if new GENI racks come, they can use a different virtualization technology. No questions?
Just one. I want to be able to create the project lead portal. So because I think I don't have the account that was.
You don't. You created an account already?
Yes, on the desktop.
Yes. So once you log into the GENI desktop, it will have a button that says request to be a project lead. Yes, just request that and put as much information as you can in the page that it will come up. Yes. I'll get there.
I don't know if this question is relevant, but then you were explaining about FIA, and am I right in understanding that it is suitable for ad hoc network experimentation also?
You mean GENI?
Yeah.
Yes. So GENI, the wireless resource we have in GENI are basically WiMAX base stations. So I wouldn't say that you can use WiMAX to do wireless ad hoc experimentation. There is the Orbit testbed. I don't know if you're familiar with it. It's out of Rutgers, which is basically Orbit is a big room where they have these wireless nodes hanging from the ceilings. And they're like, I think it's a grid of 20 by 20, so there are like 400 nodes there, all connected with wireless. And they have ways to change the path loss between the nodes. So you can imagine that you can build different type of topologies. Mobility, again, is always hard. How do you do mobility? Like, do you get graduate student walking around? Who knows? But what they've done there, the best thing you can do is use VM migration and actually move your code from one node to the other and simulate mobility that way.
It's possible I design my own controller, open flow controller in the GENI? What's the resource you provide to do that?
So I talked about that, most of the way we are trying to slice the network is using OpenFlow switches. And in the RSpec that I presented before, that you describe your topology, if you are reserving also an OpenFlow switch, you get to say, and this is my controller, it runs on this URL. So you can run your own controller. That's the whole point of using OpenFlow.
So you talked about the different infrastructure connected through layer 2. Do we have any kind of programmability at the physical layer?
No. So GENI is built on layer 2 and above. So you can assume that you have Ethernet and above to innovate, and sometimes maybe 2.5, depending on whether they're using MPLS as the link mechanism between sites. So at this point, I mean, you might be able to get within one test bed, right? For example, within ProtoGENI, Emulab, but not across different sites.
How would you help to purchase GENI? Is it possible to have it in our university, and how we can become GENI members as a university?
When you say GENI members, do you mean to be able to, for in common that I was talking before, or GENI enable your campus?
Our campus.
Oh, to GENI enable your campus. So the person to talk to, Larry Landweber, there is GENI is working on GENI enabling campuses. And you can purchase a GENI rack, I mean, if you have funding. The person to talk to is Heidi Dempsey from the GENI project office, and actually both of the leads of the GENI rack teams, both Ilya Baldine and Rick Magier, are around. So if you see them, you can talk to them, and they can convince you why you should purchase one rack or the other. Sorry, just very, very quick.
Yeah, if you're from a school and you're not sure who to talk to me, and I know the right contacts at most of the universities, so.
Thank you. Other questions?
Regarding slicing the layer 2 connectivity, I'm thinking about the international connectivity. Do we need OpenFlow all the way for the circuits, or we can do some Q&Q or something like that?
So having OpenFlow all the way solves many of the problems and is better. But the way we're doing it now, we just get a layer 2 VLAN between. So we have an OpenFlow switch in one end, one OpenFlow switch in the other end. We'll just get a circuit between the two, and that works. So there are some caveats when we do that, but for most it works. And that depends. If you don't want an OpenFlow experiment, then that's even easier, right? We would just get a layer 2 connectivity between the US and Brazil, and we've done this. The experiments we've run were actually through Florida University all the way to the ProtoGENI testbed.
Because it was only one circuit and one experiment, when you try to scale that, we would need for.
Yes. So the way we do it within the US is we're trying to have dynamic provision of the circuits. so that you can dynamically get a circuit only for your experiment. And I know that there are people, thinking about how we can expand this, how we can do it, internationally. What does it take? What are the right places? And in many places, and even in campuses, we also many times provision statically a range of VLANs instead of only one. You can imagine that between the US and Brazil, we have like 20 VLANs, and then we just dynamically allocate them to resources, but they're statically provisioned.
For dynamic circuits, can we use Internet through ION to do the circuits? Already works from Flash or something like that?
I wouldn't. Yes, Larry? Oh, sorry.
Regarding the dynamic circuits, does it use Dragon or Internet to ions, or is that different mechanism?
So right now we are running an AM that is using the Internet to ion. I wouldn't say that is open to the whole wild world yet. But there's going to be tomorrow the second session that says dynamic topologies. They're going to have a demo about how do we do that with Internet 2 and GENI tools. It's not going to be FLAG, it's going to be another tool called Omni. But yes, there is GENI tools that help you do that. And we're still, in testing mode. We're in alpha testing. So, if you're interested, I'm sure you can talk to the software group to give you access so that you can test it yourself.
I have two simple questions. The first one is my university is not a member of GENI, so actually my account is a GPO. Actually, can I keep my account after GEC? Actually, I would like to share the GENI experience with my team member or students. And the other one is, will you cover any instrumentation and measurement in the hands-on tutorial?
So the answer is yes. The account that you got with us is permanent. One small caveat is, in order to do anything useful in GENI, you need to be a member of a project. And the current policy in GENI is that only faculty members or senior technical members in companies, if we're going to the same in industry, can be project leads. So you need to get, are you a faculty member or a student? You're a postdoc. So you maybe need to get the faculty member you're working with to get a GENI account and create a project. But yes, the account you got for now is permanent, and you can use it. And to the second question, yes. So we have getting started with GENI part 1, part 2, part 3. Part 3 is instrumentation and measurements. Any other questions?
Just a quick one. If you are a faculty member and you decide to use this in a classroom and students forget to turn off resources, can the faculty member or the administrator go in and shut down the resources at the end of the class?
So we're going to see this in the exact next tutorial, but through the GENI portal, the project lead, which is usually a faculty member, is automatically added to all the slices of all the users. So and he can also ask the TA to join all the slices. So then everyone that is an admin on the slice can delete the resources. And also an email to the aggregates can say, please delete all the slices. They can do it for you. But there is a way for the actual faculty member to do it. Other questions? Okay, so first of all, thank you very, very, very much for coming. Before you leave, please complete a feedback form. So we are trying to get feedback on the sessions, and I want to hear your feedback about the talk and how we can make it more interesting or answer more of your questions. And also in every tutorial you're going to go, they will also have, they will give you a feedback to complete. You can also do this online. I don't have the URL right now, so I will urge you to do the paper version. But in the next tutorial, you can also do the online version if you prefer. So please, before you go, just fill out it. There are like very few questions. And Ben is on the door that has the feedback forms.